Good afternoon, everyone. I am your narrator, and this is the main cast of our story. First is Joao, Florida Tech student and frequent A1A biker. And as you can tell by his rad sunglasses, he is a cyclist. We also have George, his friend, another humble Florida Tech student and frequent A1A biker. Our story follows these two friends seeking a solution to a problem near and dear to their hearts. I hope you enjoy.
George, my friend, I haven't seen you so long.
Me neither. How are you doing?
I'm great. It's almost been a week. What have you been up to, my friend?
Not much, my friend. I was studying, but I want to hang out with you. You want to go bike later with me?
You want to go bike day? You don't remember what happened last time?
What happened that time?
Joao! What happened, Joao? George! A car just hit me! There's no obstruction between the bike lane and the roadways. I feel so unsafe at A1A biking. I don't think I can ever bike here ever again.
Oh, I remember now. You got hit by a car.
And I almost died. I wish there was a way we could improve the safety at A1A between the roadway and the bike lanes so we could start biking together again and have a great time like we used to. Especially, it should be a very optimal and money efficient solution.
Whoa, João, that seems almost unreal. We gotta investigate that.
I think we should go right now so we can start having fun again. Let's go!
And so our heroes set out on a journey to faraway lands, in hopes that they might find a solution to their problems.
George, we shouldn't be doing this. We should start working on our research.
What are you talking about? I'm already working on my research.
Oh my god, I'm overheating. This is too much work, George. I think I need some water.
How's it so much overheating?
Oh my god. Oh my god.
João, I think Jersey barriers would be the solution for our problem if we put all along the A1A. But there is one problem.
Wow, that's a lot of money.
Yeah, I know, man.
A few moments later.
George, I just had a great idea.
What?
We should go interview students and people that bike at A1A, like us, because they're also stakeholders in this problem. And then we can ask them if they feel safer depending on our solution.
Wow, that's a great idea. I think we should do that right now.
Oh, let's go!
Let's go!
Our heroes had many questions for the noble men and women of Evans Library, and many answers they received.
Oh my god, George, I think I found our solution for the problem. Oh, look at this, I'm gonna send it to you right now.
Okay. See? Oh, wow. I think with the lane post, if we put all along A1A, it would definitely improve the safety there.
And from our interviews that we just did, they said if we go closer together, they will feel even safer at A1A. And we could bike again like we used to.
That's That's amazing. We can talk to City of Melbourne and we can make it happen to bike again.
Oh my god, let's go!
And they all lived safely and happily ever after. Wait, you mean it's not that simple? No, of course not. You still have 3 layers of approval to go through, but we're here to explain why this is probably a good thing for both the city and Florida Department of Transportation moving forward.
Thank you so much, Connor, for that wonderful story. You're a great narrator. Now, on a more serious note, here's our actual project, the Bicycle Safety on State Road A1A. I'm Joao, and George, just as you've seen in the story. We have Connor, the narrator, and we also have Andrea Tovar. Our main challenge for this project is that there is a below average sense of security and safety at A1A for cyclists relating to the bike lanes. They're too narrow and there's no obstruction between the roadway and the bicycle lanes. So that brings a great safety concern for cyclists that are using these bicycle lanes.
The stakeholders in this project would be the cyclists and A1A drivers. We're doing this for their benefit, as well as Florida Department of Transportation and the City of Melbourne. We're using their codes and the ordinances in order to set up the lane poles.
The economy would be affected since there would be the addition of the cost of the material that would separate the road and the bike lanes, and also the construction and installation fees of it, plus any additional cost of any bike racks that would be installed. And some of the human element factors affected would be the cyclist safety, motorist awareness, tourism and seasonal visitors, comfort and confidence, and feedback and adjustments. Some changes related to energy, environment, and climate change that should be considered are the greenhouse gas emission reduction, the resilient infrastructure design, the monitoring and adaptation, and the public transit integration. And also some broader transportation systems that are affected: the traffic flow and volume, intersection design, maintenance and road conditions, lighting and visibility, data and monitoring, and public awareness and advocacy. We believe that the lane poles are the best and most affordable way to improve security for cyclists at A1A, and to verify that hypothesis, we will create a more elaborated survey to get all the information necessary, and also try to separate a specific part of A1A to display the lane poles. Thus, we will measure the percentage of accident reduction in that area and monitor the feedbacks of both drivers and cyclists through our survey. We are right if the number of accidents reduced significantly during the test period, cyclists feel safer, non-active cyclists start riding again, and drivers be more alert next to the poles.
Here are some of the alternatives for our solution. On the left, you have lane poles. Some of the pros are that they're easy to install, easy to buy in bulk, they're easy to replace. Some of the cons is that they're not very durable. It does not stop a vehicle from directly hitting cyclists. If a pole is hit, it might sit in the middle of the bike lane. On the middle here, you have cat's eye. They're easy to install, cheap, effective. But some of the cons is they also don't offer any protection against a car hitting a cyclist, and they're easy to drive over it. On the right here, you have a bicycle lane extension. Safety is greatly improved, more room for cyclists, but they're it might be very expensive. It's not viable because there's private properties on the right of the bicycle lanes, and it might affect sidewalks in some areas of A1A as well.
Our initial solution, based on the 3 alternatives just spoken about, was lane poles. They're much easier to implement. They're also much easier to see than the road studs, as well as they're a cheaper alternative.
As for the codes and ordinances used for our project, we have examples from all 3 of the City of Melbourne, Brevard County, and the Florida Department of Transportation. Each of their respective Municodes or service handbooks generally have some sort of codes that specify the want and the benefits of having multimodal levels of service on roads, such as options to use bicycles on those roads. All 3 of them view it in a positive light and have their own regulations surrounding it, which we'll get into a little bit later.
Here are some of the data that we used for our project. We created a survey sent to many students at Florida Tech. using George's RA information from last year. We got 249 answers back, and we asked the participants whether or not they would think A1A needs safety improvements and whether or not they liked our solution. We had 84% of the people say that A1A bicycle lanes need safety improvements, and 82.33% of people said that our solution is great, and 17% said that another solution would be more viable.
Our stakeholder suggestion was from Paul when we interviewed him. He let us know that if the poles were not too separated, that it would emphasize the feeling of safety. So that's when we decided also that our poles would be 2 feet apart.
For our solution, we decided to take in stakeholder advice and feedback of keeping the lane poles relatively close together, but not too close to the point where our cost would be very high. We thought 2 feet in between them from center to center would be a good balance in between. You can see on the bottom right there an elevation view drawn to scale in CAD based on a design we found on the FDOT specifications website and approved products list that we'll talk about in the coming slides here.
About our lane pole hypothesis, we believe that the implementation of lane poles is the most affordable and best way to improve the security of cyclists at A1A, and we observed that 84% of people that answered our survey would feel safer with our solution. From that, we learned that separate bike lanes are the top factor in deciding to ride, and lane poles are hard to be ignored by drivers. Therefore, with this information, it was able to improve our learning, and we will be able to discuss it with City of Melbourne.
Here are the lane pole details that I previously mentioned that we drew in CAD based on the ones we found on the FDOT approved products list. We decided on white as our color as it intrudes less on the aesthetic of the area surrounding A1A. They have 2 3-inch reflector wraps at the top to improve visibility during the darker hours of the day. They also have a drain hole at the bottom and a small base, as you can see there on the right. To reference the codes we touched on a little bit earlier, the City of Melbourne Municode has several instances where they wish to promote alternative modes of transportation to provide a safe and efficient multimodal system. And as it stands currently, we do not believe that is the case. Even if the bicycle lanes do exist on A1A and other roads within Melbourne, no one is using them because they do not feel confident in their safety while using them, thus making them not as appealing as an option to use as transportation for the people who live here. In fact, while we were driving to the film site of our video, we saw about 4 people riding bicycles, none of which were using the actual bike lanes afforded to them by the road. All of them were using the sidewalk on the southbound section of the road, even if they were traveling north. Onto the codes provided by the FDOT, specifically those found in the Multimodal Quality and Level of Service Handbook, Section 8.1 on bicycle lanes. There are 3 different classifications for bicycle lanes. We believe A1A has marked shoulders as the design speed is less than 45 miles per hour, and it meets the clause that paved shoulders can also serve as bicycle lanes when they are at least 4 feet wide. And after driving through A1A the other day to confirm our suspicions, there are certainly sections where the shoulders are less than 4 feet wide, even though they are still marked as bicycle lanes. The bicycle lanes at some points are even completely phased out, especially during right turns, and it's entirely unclear where the cyclist should continue their path. Referring to FDOT specification number 704 for tubular markers and its respective approved products list, we decided that our lane poles used would be U-Flex surface mounts supplied by SureTight products, as they do not interfere with the aesthetic of the area too much, and they have installation instructions found on both the FDOT website and their respective website. These poles are made of polyurethane and are bound to the pavement with an epoxy resin.
For our project cost, we're calculating about 15,840 lane poles necessary for the 6 miles with those 2 feet of separation in between them. This isn't taking into account any of the extra separation that we need for the right turns or any other extra separations that we might need to be on the road. The materials would be the epoxy and the lane poles themselves, as well as then the labor, which we calculated to about 20 workers, and that would make 20 lane poles per hour. The operation and maintenance cost, on average, each post would have to be replaced 6 to 8 times per year. That would also take into account the extra epoxy needed as well as the lane poles themselves. Labor also accounted in there. It's also important to know that this is for just one lane, so we would need two since there's two sides of the road. Yeah.
Some of the benefits that come with this project is that the number of cyclists will greatly increase if the lane poles are implemented in the bicycle lanes. I think that if they feel safer, more cyclists will start going A1A to cycle. The number of accidents will also greatly be reduced. And the land appreciation is also very important because if we have more people using A1A, all the business and even private properties around A1A will be greatly appreciated. The travel time will also be reduced. We'll have less traffic at A1A because more people will be cycling. And cyclists can, if you live right at A1A and there's traffic for some reason, you can just cycle 2 to 5 minutes to a restaurant or a supermarket, and it will be way easier to get in your car, and you will also save fuel and help the environment. Considering other solutions for our problem, our solution was the most cost-effective of them all. It's about $6,200 for a 6-mile extension on both sides with lane poles of A1A between the bicycle lanes and the roadway. Some of the benefits, like I said before, are a great increase in number of cyclists at A1A, reduction of number of accidents. It's way more feasible than utilizing jersey barriers or bike lane width extension. It's way cheaper than jersey barriers. It's about double the amount of money with jersey barriers to use that, and we would also have to have a bike lane extension for the jersey barriers because their width is way bigger, and it would affect the roadway, and it wouldn't be very feasible. The lane poles are definitely the best alternative for our solution. Thank you, everyone. I hope you enjoyed our video and our presentation. Our project, once again, the objective is to improve safety for cyclists on State Road A1A by utilizing lane poles between the roadway and the bicycle lanes. Now we'll take any questions and applause.